So good morning to all. I'm here on behalf of Adrien Becu, the project coordinator of Secoiia, the Secure Collaborative Intelligent Industrial Assets project. I am Isabel Praça from Polytechnic of Porto, and I'm the impact manager in this project. Can you go on with the next slide, please? This is our mission with this project is to enhance security and safety for collaborative manufacturing. And for that, we rely on transportation's use cases, covering aerospace with an use case led by Airbus, automotive covered by Continental use case, and maritime covered by Naval Group. We have three end users on board to demonstrate somehow the generical and the applicability of the capabilities we will develop. And our path is focusing on a comprehensive approach regarding different types of collaboration within digital manufacturing. That is machine to machine, machine to human, human to human, and organization to organization. Another very important key point for us is the hand-to-hand data security and process safety from shop floor to cloud. This project just started in December 2019, so we are now in the third month of execution. It is a 30 months duration project. Could you please go on? Okay, so we have a consortium of 12 partners. 8 countries are involved, and we have big industries, mainly assuring the requirements and the pilots. We have then SMEs, and we have academic and research partners to ensure development of innovative services and new solutions to the market. I won't go into details, but there are from 8 countries. So in our view, the collaborative manufacturing ecosystem with the digitization, the vertical supply chain tears down into an horizontal supply chain where besides suppliers and manufacturers, we also expect a very um, very huge and demanding involvement from customers since the early beginning stage of production. We also foresee new players, new services, and new players are expected, and in particular, cloud manufacturing service providers. In this figure, you can see not just the process flow, but also the information flow and how these new players are into to be interacting in the future. Next, please. Now let's go a bit deep into the use cases we have. So the aerospace use case relies on Airbus factories, the factories of Tablada, São Paulo, and Cádiz. And the main goal here is to collect data in real time from different robots and from different tools in the factories, in these 3 factories, provide a layer for AI analytics to improve process monitoring, optimization, and control, and to involve the collaboration and to spread the collaboration between robots to support human operators in some of the activities. For this use case, the main misuse cases we highlight are the insider threat and adversarial machine learning attempt. And the main, I don't go into that to a lot of details. Otherwise, I think I will go behind the time that is available. But I would like to mention the key capabilities, which are the collaborative OT Security Operations Center, the cognitive and emotional behavior analysis, next generation OTIDS, adversarial robust machine learning. These capabilities, I will later on systematize them in a picture so they become more visible to all. But now we can go on to the automotive use case, please. Okay, so the automotive use case is hosted by Continental. And the goal here is to have a secure cloud manufacturing infrastructure so that it improves traceability of secret exchange with suppliers and to use crypto key exchange infrastructures and scale up to big data. In this case, the misuse case we will address is the Byzantine fault attack hack, which as the Byzantine faults occur when parts of a multi-cloud based management systems fail due to arbitrary faults and intrusions. The capabilities we want to show here are the Byzantine fault tolerance, resilience, federated identity and access management, fine-grained access control, and encryption. Next, please. For the maritime use case, we have a pilot at Naval Group Factory of Lorient, and the goal is to show the secure sensitive manufacturing. So to give access from the supplier to perform remote maintenance on the customer. We will use data extraction out of the factory and some challenges like to secure the information exchange gateway and the monitoring solution and smart detection agents and cyber monitoring. Also some AI capabilities in the detection reaction base. The MIS use case, sorry, Chris, just finishing. Yeah, thank you. The misuse case is ransomware on Windows applications that are monitoring the robotic arms, actuators, and APT attacks. In this case, the main capabilities are the next generation OTIDS, a collaborative industrial cyber range, IIoT authentication and encryption. Next, please now. Yeah, so with this pilot, we have our approach driven by these use cases, but we intend to explore generic aspects to deliver a value proposal that can apply to other manufacturing sectors. So from the needs of the automotive, aerospace and maritime, we have the need to empower and enforce law, to create trust and protect, to detect and react, to identify and to prevent. And the capabilities that we will deliver are related to a secure cloud manufacturing backbone, a collaborative OT SOC, an industrial cyber range platform, and to be the basis of a digital twin and the accountability framework. Next, please. We identify several degrees of collaboration in a collaborative manufacturing environment, starting in a low level with the usual communication between machine to machine. Then we have the layer with the machine to human collaboration, which achieves now a different paradigm where we don't have exactly robots performing the tasks by themselves. We have robots collaborating with human operators, and somehow also the robots need to learn with the human operator itself. Then we have the human-to-human collaboration related to different level of decisions, to human resources, to dynamic distributed manufacturing, to prediction and to optimization capabilities. On the top, we have organization to organization. So we need cross-organization collaboration tools, contractual and legal supply chain management value chain. So we need a data lake, and we also need trust enabling technologies to make knowledge, make services, and make business out of this data lake. Next, please. This is the high level of our project structure and somehow also of our architecture. We can see here in the middle the different degrees of collaboration that I was mentioning, and how we will address our goals of create, trust, and protect on the top layer with IIoT authentication and encryption, combined asset and user authorization, and fine-grained access control and encryption. On the left side of the screen, we have the capabilities related to collaborative industrial cybersecurity training and simulation capacities. So this is focusing on the need to identify and to prevent. And here we have an OT testing platform, digital twins, and tools to community training. And this is where the cyber range plays a very relevant role, integrating a digital twin applied to OT security. On the right side of the picture, you can see the Collaborative Security Operations Center for distributed operations. And here we foster the next generation of OTIDS, the human machine behavior analysis and enhanced collaboration. And for this, we also rely on human cognition, identification, and strategies driven by this human behavior analysis. On the bottom layer, we have the need to empower and responsibilize. For this, we work on adversarial robust AI, a very important topic to spread AI into these organizations, and the responsibility framework and the collaborative OT security forensic. Go on, please. We are organized in 8 work packages. I will not take long here. So the coordination, then use cases and requirements together with impact management. This lasts for the whole duration of the project. Then we have training and simulation capabilities, feeding the secure cloud edge manufacturing and the collaborative factories of the future. And then the accountability framework and of course, integration and demonstration in the 3 pilots. This is the summary of innovations that we propose. As you can see, we have the different types of collaboration has different layers, and we have the different goals as the verticals. So preparedness, information security, process safety, and social liability. I don't know, Chris, if I should go fast or.
Well, yes, but I think this slide I think is quite impressive in terms of an overview.
Yeah, so it is indeed important. It gives the global picture of the project and as well as the capabilities that we will develop. In this layer, I will start by the low layer, the machine-to-machine collaboration. And here,
Isabel, if it's okay, I would indeed try to wrap up, and for sure we'll engage also in more detail about this and promote, but just trying to make sure that
just to show we have these metrics of innovations that will be also the capabilities we achieve at the end of the project. So thanks, let's go on. And here we have the view on how those innovations will be covered by the use cases. All of them are being covered. We have a joint demo, which is here highlighted in green. So these capabilities will be covered by a joint demo, and then some of them in the particular transportation sector. We can go. And the impacts, scientific impacts, technological impacts, here I highlight the cyber range and the next generation OT IDS, the operational impacts on the collaborative OT security training, the cloud manufacturing, and the accountability, the normative issues with the accountability framework for Industry 4.0. I think just to finish, this is the timeline of our project. We are now in month 3. So we are doing the architecture and the requirements definition. In summer, we expect to have a preparedness workshop for it. We will invite all these projects that are in the workshop, and yeah, we stay tuned to let you know news from our developments.